Hello everyone. I am Laxman Lonkar Lecturer in Electronics, Govt Polytechnic, Washim. Today we will see there means actually we can perform practicals in as well as some simulations on simulation software. There are so many simulation software like multisim. For the analog electronics, we can have multisim, then Pascal, then this virtual lab also shared by NIT. This is you can see this is a virtual lab for all engineering disciplines. Means suppose we can take an example of electronics department. Suppose this is a basic electronics. For basic electronics, this is the link. On this link, once you will go in on this link, we'll see there are some practicals you can perform online, and it is too simple. It will not take more than 5 minutes to perform the practical. It's just plug and play kind of practicals. Let's see LIC practicals. So for the LIC practical, we need to go for we need to click on this analog electronics. So OPAM is analog IC, so we can perform analog practicals. For this analog practical, we need to click on this first link. There are two links actually, so we need to click on first link. Once you click on first link, we'll see this many practicals we can perform under this tab. So log amplifier, anti-log amplifier, vein bridge, voltage V2 I converter, voltage comparator, and unstable multivibrators. So we'll see one by one. First we'll see log amplifier. So actually there are these are the tabs. Under these tabs we have to visit all these tabs because all these tabs are so important. So this is the aim. After aim, this is the theory. Actually you have to study this theory, or you have to go through this theory because there is a one actually we will see here there is a pre-test on this theory. You have to appear for the pre-test. So once you read this theory, you have to solve this quiz. You can submit. There are only 5 questions you have to solve. So after reading this theory, you have to attend this quiz. You can submit this. Let's move towards the procedure. So procedure is too simple. Just you have to connect. There are some point like L1, L3, then L4, L7. Just you have to connect, and you have to perform the practical. Suppose we will see first log amplifier. So this is the procedure. Okay. So you can take a snap of this procedure, or you can just if you know the circuit of log amplifier. So suppose I will show you the circuit. If you know the circuit of log amplifier, then no need to even though see the procedure. Just what are the connection? You need to connect one source to the inverting amplifier. Then in feedback we have to use diode over here, and in initial path you have to use one resistor, and for non-linear you have to connect to the ground, and you have to take an output by using this pin number 3. So this is too simple circuit. So let's go towards the simulation. So under the simulation there are 2 tabs like anti-log amplifier and log amplifiers. First we will see log, and in next video we will see anti-log amplifier. So just click on log amplifier. So this is the circuit of log amplifier. See, there are this is the component, like this is the resistor component, this is the diode. So we have to connect, right? So we know that we need to apply inverting supply to the inverting terminal. So let's connect. Or you can suppose if you forget the circuit diagram, then here in the instruction tab you have to just click on instruction and follow the procedure. So first procedure, like suppose L1 has to connect it to the L3, comma. That means L1 has to connect it to L3. That's it. After comma, there is a second connection. L4 is connected to the L7. Third connection, L5 is connected to the L7. First of all, I will show you 1 or 2 connection. Then I will just keep all the connection because as time bounding video. So just L1 connected to L3. So this is L1, right? Where is L1? This one. This one is L1. This L1 has to connected to L3. Just drag and drop like connection. Just click to the L1 and just drop it towards the L3. So this is the first connection, right? So second connection, what is second connection? Second connection is L4 to the L7. You can show here. You will see over here L4 is connected to the L7. Now then just click on. Here is L4, and that L4 is connected to the L7. That's it. Then just click on instruction. L5 is connected to the L7. L5, this is L5. Again, this is connected to L7. Actually, I know the connection, so I will make the connection as per the instruction. You can see instruction if you have any queries. This L6 to L9. Then you have to connect non-inverting terminal to the ground. So I am connecting the non-inverting terminal to the ground. And this is a CRO kind of thing, or this is a plotting thing. You have to connect these terminals, or you means for the output. You can see over here in the this is a reference of CRO, means kind of CRO. So you can, for positive and negative, you need to connect. So output is connected to the positive terminal. There is pin number 10, and for the negative, you connect the pin number 11 to the ground. That's it. So this is connection. So if so, you can check whether that connection are correct or not. So just click on check. After click on check, so you will see one tab. So right connection, right? If you have connect any wrong terminal to the another terminal, then it will show you connection is wrong. Again, you need to check in instruction, and you need to connect or you need to connect proper connection. So this is a right connection. Therefore, I will click on OK. After connection, you just need to follow the next procedure. What is the next procedure? So see, procedure is also given over here. Set the input voltage to 1 volt, right? Then these are the terminal. These are the process, or these are steps. You can read and you can follow the procedure. So after you just need to set 1 volt. Okay. After 1 volt, just calculate. Click on calculate. So this is a negative voltage I got. That is 170 point something, right? So just click on add to table. Again, calculate for. Actually, we need to calculate the reading for every 1 volt. So after 1 volt, you need to calculate for 2 volt. Actually, 1 volt here 1 volt means 100 millivolt, right? So for 100 millivolt, we got this much output minus 170, right? So again, we need to take another reading for 2 volt, that is 200 millivolt. So 200 millivolt will get minus 188. You can see over here, or you can add to this table. See, from this 2 reading, we can calculate, or we can assume that we are increasing input voltage to the multiple of 100 millivolts, right? Suppose I will take another reading for better understanding. So for 3 volt, just calculate, we will get minus 199. For 4 volt, we will get minus 206. See, we have this 4 reading. For these are the multiple of 100 millivolt, right? 100, then 200 millivolt, then 300 millivolt, then 400 millivolt. Actually, from this output voltage, we can assume, or we can observe, voltage is decreasing is the multiple of only 10 volt, right? See, this is a 170, and again this is a 188. Means the voltage voltage is decreasing only of 18 volt, right? 18 millivolt. So that means the difference is too small. Means you can assume, or you can conclude from this practical, we are getting output is as a logarithmic output. Input is nothing but the log of, or output is nothing but the input of log of input, right? So for the 5, you can take 5 reading. See, this is the graph. After 5 reading, we will get the graph. From this graph, see, these are the input voltage, means for 1 volt, 2 volt, 3 volt, 4 volt, up to the 20 volt. We need to select up to the 20 volt, and we will get this exponential graph. Because why it is exponential? Because we know that the output is nothing but the exponential of the input voltage, right? And it is in minus sign. So this is the graph. Actually, suppose we can by using calculator also you can calculate the output, so they will get the same output by using calculation also. So in the calculator you can calculate, suppose this is the I use online calculation, or you can calculate on your calculator also. Suppose this is log of 1, right? So what is the output? Output is 0. Or log of 2, so output is, see, output is 0.63, right? 69, sorry. Then for log 3, output is 1 point something, means only 40. Difference is only 0.69 is 70 around, so only 0.30 is the difference only. This actually we can say from this log amplifier, it is decreasing in a voltage very slowly, right? So it is a main difference between log and amplifier. In anti-log amplifier, log and amplifier, the difference between log amplifier and anti-log amplifier. So in anti-log amplifier, we'll see the voltage is increasing very rapidly. Means for 100, for only 50 millivolt, it will give too much of output voltage. So in next video, we'll see anti-log amplifier. Thank you. If you have any queries, then you can just raise the question and you can ask me. Okay, thank you.